So non-sampling, it's not my sample, it's some other issue. How I ask the question, I may type it when I write it down, something like that. Sampling is because I have a bad sample. So if I ask you guys, how much do you study? Well, you are in a college level class. Do you think you are more likely to spend time outside of the classroom doing homework than some of the other people in our high school? Absolutely. So the group of people I ask are different than the entire population. So two different ways we could have error in what we're in the results we're getting. Any questions there? Okay. I'm going to go ahead and cover the last section. And I'm going to be pretty vague here. We're talking about it's dealing with the design of experiments. I am not going to go into all of this in depth because we're not going to do a whole lot of setting up an entire experiment, but we just kind of need to know some of the basics behind it. So I think we have more vocab, right? Vocab sheet, we're gonna finish this up. So when I'm talking about an experiment, again, I'm not just going to give you a vocab test, but this is so when I say words throughout the semester, you know what I'm talking about. Do you want me to just pause this and let you write for a minute? You can feel free to paraphrase. So when we're talking about an experiment, that's just like a controlled study. So we talked about before the difference between observational study and a design experiment. Observational, you're just sitting back and watching. An experiment, you're actually doing something. So you're varying the explanatory variable. And another word for that is a factor. So the explanatory variable or the factor, that's the thing you control. And you're measuring the response. Okay, so maybe I want to do a study and see if listening to classical music makes my students perform better on a test. So the explanatory variable or the factor, what's the thing I'm going to control? The music. The music, if you listen to classical music. And what is my response that I'm measuring? How well they do. How well you do on a test. Okay, the subject would be like you guys, the people that I'm doing this to. Those are my subjects. The control group is like your baseline. So I might have two classes. One class takes a test with classical music, one takes it without. So the class taking it without would be my control group. They are not having that factor for the explanatory variable. Okay. And in medical trials, you hear a lot about placebos, like a sugar pill. You take that, so you don't know if you're getting a real medication or not. What's the purpose of something like that?
So that you don't injure yourself if you think you're having side effects.
Right. If we're trying to see if a new medication makes you feel better, you can't just say, well, you're going to get medication and you get nothing. Well, of course, medication, the person that's taking a pill might think they are feeling better just because they're taking a pill. So you give both people. One might be just a sugar pill, one's a real medication. See if there's an actual difference outside of the mental profile. All right. Any questions there? In a lot of these studies, they might be a single or a double blind. In a single blind, that would be like the medical trial where one person gets a real pill and one gets a fake pill. You don't know what you're getting. If you knew you were only taking a sugar pill, then obviously you're not going to think it works. A double blind is when nobody knows, not the researcher and not the patient. Nobody knows which one they're getting. Let's look at some samples. The English department of a community college is considering adopting an online version of the freshman English course. To compare the new online course to the traditional course, a faculty member randomly splits a section of her course. Half the students receive the traditional and the other half is given an online. At the end of the semester, both groups will be given a test to determine which performs better. So who are the experimental units?
The students.
The students, the freshmen in this course, the students in the course. our population here?
Students taking this class.
Yeah. The freshman English students or students in her class. The treatment. What are the different options? Okay, those are the only two options. Every student is placed in one of those. Okay, what is the response that we are measuring?
How well they doing?
We want, at the end, every group takes the test to sort determine who does better. So it's the test score. All right. Why can't this be done with blinding? So a single blind or a double blind? Yeah. If you take a class, you know if you're showing up or if you're online. And me as a teacher, I know if I'm looking at you or if you're online. So both parties are going to know if they're online or not. Any questions about that? Okay, I am actually going to skip until we get to the last few definitions. So I'm going to skip a couple things on our example sheet, but we'll hit it later on when we'll use it. I want to talk about matched pairs. So if I'm creating an experiment, in this, the units are paired up in a way that they are somehow related. I'm going to go ahead and I'll just put the other definitions on here. And then we'll talk about them. So matched pairs, our data is paired up. So that might be a pre-test, post-test. You're coming into a class, I give you a test over the stuff I'm about to teach to see if you know it. Then I give you a test after I teach it and I'm seeing if you improve. So I'm going to pair your data. I'm not comparing you to the rest of the class, I'm comparing you to yourself. It might be that you have a survey and you give it to a husband and a wife. Okay, it's two different people, but aren't they somehow paired up?
Mm-hmm.
Yes. Maybe I'm going to compare like a father and a son, and maybe their height or something like that. You know, so we could look, all of those we can understand how they are related. So in matched pairs, I'm comparing the data to another set, but they're related in somehow, not just everybody. We also might set up experiments where we have what's called a block. So a blocking, it's a way of dividing people into groups. So maybe I am talking about classical music to see if it helps. And I am going to take, I think your GPA makes a difference on if it helps. So I'm going to take all of the 4.0 students in there in one group. And then all the 3.0 to 4.0 students are in a group. And the 2 to 3.0 are in a group. And then in each of those groups, I'm going to break you out, and then half of them listen to classical and half don't in each of them. So I had some means of dividing people. And then within those groups, I randomly gave them a treatment. That's your randomized block. So the block is how we decide to divide people. It might be age, it might be GPA, it might be like, if you're looking at like a lot of the election polls, sometimes they do things based on demographics, age, income, all kinds of different things that they use to separate people into groups and then make comparisons. So these are just some terms that you're going to hear when we talk about experiments, mainly matched pairs. That's one that we will use a lot, especially at the end of the course. So one final example of the day. Xylitol has proven effective in preventing dental cavities when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and were asked to evaluate the taste of each. The researchers measured the children's ratings of the two types of milk. So this is just taking an experiment and seeing if you can kind of pick out some pieces to it, which is all I'm going to ask you to do at this point. What's the response? What are we looking at here? Yep. You want to know how they rate the milk? That's the response I care about. Okay, think of some of the factors in the study. So what are factors? The variables, okay? Which of them are controlled, which one is being manipulated? So, control factors, some different variables that we are controlling. Or maybe we should start, which factor is being manipulated? The milk with or without the xylitol. That's the thing I'm controlling. Or sorry, the thing that I am manipulating. Some people, sometimes you get it with, sometimes you get it without. We're going to control or see what you think. Are controlled variables. They're children, so maybe age. Can I control and make sure everybody is the same age?
Yeah.
Yeah, if you ask a 2-year-old, they're probably not going to give you a consistent answer. They might change their mind a lot. What else could I kind of control and know?
There are Peruvians.
The number of kids, where they're from. So we were only looking at the fact that they were Peruvian.
So specific. Is their milk different? Like
Right. Maybe. Could I have control? I didn't mention it, but gender. Could I watch and make sure? So those are things that I'm not testing specifically, but I can kind of control those things. What's the treatment then? It's kind of the same as the factor that we manipulate. It's the milk with or without the xylitol. Okay. How many different treatments are there? 2. They either get it with or without. No other option. Everybody gets milk. Okay, what type of experimental design? Is this blocking? Did I separate them into groups?
No.
No. Now, if I had done like 0 to 5, and then 5 to 10, and 10 to 15-year-olds, then that would be blocking. So we're looking at, it says the children were given the milk with and without. So what it's saying is one child actually drank both cups of milk and compared them. So which type would it be? Matched pairs, because I'm pairing up their response to the milk with and the response to the milk without. Okay, the experimental units. The 75 kids that we said. Why would it be a good idea to randomly assign whether the child drinks the milk with xylitol first or second? Yeah, eliminate the placebo effect. That's a great answer. Any other answers? Different palate. Maybe it tastes different if you've already had some. Maybe it's really, really hot. So right now, if you were to sit outside for 30 minutes and I come hand you a cold glass of something, do you care really what you're drinking? No, you're hot. So the first glass might taste better just because you're hot, okay? So those are all good reasons why we would want to mix up, just to kind of eliminate order.
I might care if you come out and it's 96 degrees and you can't be glass.
Oh, that would be awful. So we talked about some, and you could have answered with any of those. Why would it be a good idea to double blind?
So that they can't give up away like which thing they're tasting.
It's obviously a single blind because the child doesn't know which milk they're getting. But it's also probably a good idea to double blind, to have one person out there filling the cups, and then the person that hands it to the kids, maybe you don't know. Because is it possible? I'm like, okay, try this glass of milk. All right, I'm gonna try this one. It's really good. Would that possibly have an impact? Yeah, if you have a little kid, you're like, oh, this one's really good. They're going to think it tastes better. So you don't want to give it away. You want to make sure your experiment is really valid. So that would definitely be a good idea. All right, any questions for me?
Because like a double blind is the same as like if you put one green dot in a cup and one red dot in a cup and the researcher doesn't know which one means which.
Yep, absolutely. Okay, so you have the 4 or 5 handout from yesterday, if you haven't finished, and I posted one today for section 6. So you can put all of those together.